Hey, welcome to my solving and graphing inequalities video. Let's go ahead and get started with working on this first problem. 3x minus 8 is greater than 13. We're going to treat this just like an equation where we have to get x by itself. To begin, we want to get rid of this minus 8, and we're going to do the opposite, which would be to add 8. So we're going to add 8 to the left side of the equation, just like we would in a normal equation. Remember though, in algebra, whatever you do on one side of the equation, we must do it to the other side. So we're going to add 8 to the other side of our inequality. And we're going to tally up what we have left. So on the left-hand side, 3x is all that remains. We wanted that because we didn't want this minus 8 here anymore. And on the right side, we have 13 plus 8, which gives us 21. We still have our greater than sign, so let me bring that down. And the last part to getting that x by itself in this inequality is to get rid of this 3, which is connected to the x by multiplication. So the opposite would be to divide. 3 divided by 3 cancels each other out. We left with just an x. Again, if I divide the left side by 3, I must do the same on the right side. Divide that by 3. 21 divided by 3 gives me 7. So I'm left with the inequality x is greater than 7. So now I'm ready to graph this inequality. So let me go ahead and put a couple points on here. And since I'm talking about the values of x that are greater than 7, I'm going to put 7 right in the middle. And then I'm going to put a value below it and put a value above it. And to graph this, if we have a greater than sign or a less than sign, that indicates that we are going to have an open circle at the point where our x is solved. So we will put an open circle above the 7. That's indicating that we're talking about all the values of x that are greater than 7, but not including the 7. So that's why it's not a colored in or a darkened in circle. It's open, indicating 7 is not part of the solutions to this inequality. So now I need to decide what side I'm going to shade on. Will I shade left or right? Well, I'm talking about all the values of x that are greater than 7. And so that means I'm going to be shading to the right. So everything in this direction will be solutions to this inequality. If you're not sure which side to shade, you can, if you get your answer written in this form where the variable is first and your number is second, you can kind of use the inequality sign as kind of like a guide, because this kind of looks like an arrow that's pointing to the right. So that's one of the reasons, one of the tips that I use to help me decide to shade to the right. All right, so let's look at another one. This one's a little bit different. Let's go ahead and work this out just like we did before. We want to get x by itself again in this inequality, so I'm going to first add 5 to both sides of my inequality. Doing so leaves me with a negative 4x on the left-hand side. And then on the right-hand side, 19 plus 5 gives me 24, and I still have the less than or equal to sign. All right, so my last step would be to get rid of this negative 4, which is connected to the x by multiplication. So again, I would divide by a negative 4. Again, rules of algebra say I must do the same thing to the other side, so I'll divide this side by negative 4. The negative 4's on the left cancel out. 24 divided by negative 4 on the right side should give me a negative 6. Be careful with your signs. Remember, positive divided by a negative gives you a negative answer. And the next part is the sign. Because I had to divide both sides by a negative number in an effort to get x by itself, that forces me to flip this sign over. So, a little star here, a little rule. If you multiply or divide both sides by a negative number, that's an A right there, you must flip the sign. Okay? So in an effort to get this x by itself, I had to get rid of this negative 4, so I had to divide to get rid of it. Dividing by a negative causes us to flip our sign. So the last piece to this is just to graph this equation. Again, I'm going to put in the center here the value that my x is greater than or less than or whatever, how it's related to this -6 value. I'm going to put a number below it, and I'm going to put a number above it, and I'm going to put an open circle above the 6, but because I have the or equal to part, it gets shaded in. So this is a closed circle because we're including the -6, not just talking about all the values of x that are greater than the -6, but we're also including the -6. And now, determining what side we shade, as you can see, our greater than sign looks like an arrow pointing to the right, so we're going to be shading everything to the right. So all of the solutions that are greater than or equal to -6 are the solution to this inequality. All right, let's look at one more similar to this one, where we have to again get x by itself. The first move I'm going to make in this one is to get rid of this positive 11 by simply subtracting 11 from that side of the equation. Again, I must do the same thing to the right side of the equation, so I'll subtract 11 from that side. When I do so, I'm left with a -7x on the left side. Don't lose track of that sign. That sign is still there with that 7x. And over here, I believe I come up with a 28. And then I just bring down the sign that I have. So the last move is to get rid of this -7, which is multiplied to the x. The opposite of multiplying is to divide by -7. Again, if you divide one side by something, you need to divide the other side by the same exact value. So I'll divide the other side by -7. I'm left with an x on the left side. And I think 28 divided by -7 gives me a -4 on the right side. And again, because I multiplied or divided in this case, by a negative number, the rule says I have to flip my sign. So what was less than or equal to becomes greater than or equal to. So let's finally do a graph of this. My -4 goes in the middle. I'll pick a value smaller and a value bigger. And I will put an open circle above the -4, but I notice that I have an or equal to sign, which means I need to color that in. It is no longer an open circle, it is closed, because we are including the values of -4 as far as a solution to our inequality. And again, I notice that my sign is pointing to the right, the greater than sign, so that indicates to me that I'm going to be shading everything to the right of my closed circle. All right, so let's look at one more of these. This is a decimal, but we do it exactly the same way. We're going to again try and get x by itself by first taking care of this 1.4. I'm going to subtract 1.4 from the left side of the equation, but again, I need to do the exact same thing from the right side of my equation. Algebra's balancing out everything. It's very key that everything stays balanced. On the left side, 0.3 or just 0.3x is all that's left. On the right side, I think 0.5 minus 1.4 gives me 0.9 negative. And then I have to remember to bring down my sign, that less than sign. So my last move is to get the x by itself. Currently, it's being multiplied by negative or by a 0.3. So I am going to divide by a 0.3. But remember, the rule of algebra says if you do it on one side, you must do it on the other side. So I divide the other side by 0.3 as well. These 0.3s cancel each other out, and I'm left with just an x. On the other side, a negative divided by a positive will give me a negative answer. Negative 0.9 divided by 0.3, I believe, comes out to be a 3 for an answer. And I just bring down my sign. Now, how come I didn't flip my sign over? How come it didn't become a greater than? Well, I divided both sides by a positive 0.3. When you divide both sides by a positive number, there's no rule that says we have to flip our signs. The sign stays exactly the same as it was. That only happens when you have to multiply or divide by a negative number in an effort to get that x by itself. So here's my solution. I'm going to go ahead and graph it. -3 in the middle, one number lower, one number higher. put an open circle above my answer, and it stays open because this is not an or equal to. We're not including the value -3. We're talking about every value of x that is less than that, but not including that. And since we're talking about the less than values, we can kind of get an idea of a little arrow here pointing to the left. So I'm going to be shading every value to the left of -3. All right, we have one more thing to look at. You'll often see a question that asks which are solutions to an inequality like this. And you have to choose all answers that apply. So here are all the possible answers to find which ones are the right ones. You can do this a couple different ways. You could take each of these numbers and plug it in place of x and see if when I plug it in place of x, it creates a true inequality here. Or you could solve this inequality and then see which of these numbers applies to being a solution to the inequality. I like the latter. I'm going to go ahead and solve our inequality. So I'm going to rewrite it down here. -6x plus 7 is greater than -29. And I'm going to begin by getting rid of this +7. So I'm just going to subtract 7 to make it go away. But remember, you must do the same to the right side of my equation, leaving me with a -6x on the left, and I think a -36 on the right. Bring down my sign. My last move is to get rid of this -6. I must divide to get rid of it. I must do the same thing on the right side. Remember, balancing my equation, everything that happens on the left must happen on the right. These two -6's cancel out, giving me just my x, which is exactly what I wanted. These two negatives create a positive answer. 36 divided by 6 gives me a 6. But because I divided both sides by a negative number, the rule is I must flip this sign. So instead of a greater than, I have a less than sign. So all we have to do now is determine which of these answers is less than 6. Is -4 less than 6? Of course it is. Is -3 less than 6? Of course. How about -6? Is that less than 6? Certainly it is. How about 6? Is 6 less than 6? No, 6 is equal to 6. So this is not a solution to this inequality. 5, that of course is less than 6. And 8 is not less than 6. 8 is greater than 6. So the correct answer to this is -4, 3, -6, and 5. So if you see a question like this, don't get flustered. Just solve it like you normally would, and then determine which of these answers, and there might be more than one, makes this inequality true. Okay, I hope you learned something from this video and that it helps you when you get to your SOL. Have a great day, guys.